So our net change theorem says f of b, that's capital F, meaning the antiderivative, of b equals f of a plus integral from a to b of f prime of x dx, or, and I feel like a lot of this is now kind of common knowledge, the integral from a to b of f prime of x dx is f of b minus f of a. So we evaluate the antiderivative at the upper limit minus the lower limit. That's a net change theorem. Very related to the fundamental theorem of calculus part 2. So this would account for when you have a positive area and a negative area, you subtracting. Okay. Given the velocity function v of t equals 3t minus 5 in meters per second. So it was v of t equals 3t minus 5. For particle in motion from t equals 0 to t equals 3, find the net displacement of the particle. So net displacement we'll talk about, it's simply going to be that integral from 0 to 3 of 3t minus 5 dt. Hello? Was there a question? Okay. So if we integrate that, we would have 3t squared over 2 minus 5t, and we evaluate that from 0 to 3. So that means we're going to have 3 times 3 squared over 2 minus 5 times 3, and then subtract from that 3 times 0 squared over 2 minus 5 times 0. Now I think you see that second part is all just going to be 0. So the first part's going to be 3 times 3 squared, 3 squared is 9, 3 times 9 is 27. So 27 over 2 minus 15. That's going to be 27 over 2 minus 30 over 2 to give us negative 3 over 2. So that's just integrating, and then that's going to account for, and I want to draw this shape if you don't mind, once you finish writing these down, just to get an image of what's happening. Because the next part, we're going to look at the total distance traveled. So this is the net change. The net change is a negative 3/2 meters. It's been covered by looking at area under the curve. So I'll just draw it over here. So if we were to look at a graph of this, so 3t minus 5 has an intercept of negative 5. 1, 2, 3, 4, 5. So intercept is negative 5. The slope is 3. So up 3, 1, 2, 3 over 1. Up 3, 1, 2, 3 over 1. Something like this. And we're looking at the area from 0 to 3. So let me change colors again. So it's, why isn't it drawn in color? So here and here. So that's the area, and obviously the area under the curve is more than the area over the curve, which is why we have a negative net area. Now, in the second case, is there a question about that? So that's our net change is negative because the stuff below was more than the stuff above. Took the absolute value. Okay, now, in the second question, it's asking us about the total distance, so not the net distance. So imagine if you went so far this way and then so far this way. The net distance just talks about that part there, that overall in the one direction. Whatever had more, how far was that? In the total will be that if you're doing this kind of pathway and then back that way, you're going to have that full distance this way plus the full distance, the other part of the distance. Distance is not measured as negative or positive. It's always considered, or not measured as negative. You can't say I'm negative 5 miles from something. I am 5 miles from something. Okay. So in this case, we account for the stuff that's below the curve. So if we look at this 3t minus 5 and set it equal to 0, we have 3t equals 5, or t equals 5/3. 5/3 is where this graph crosses the x-axis. So I'll use a figure, and I'll draw a picture of it, to find the total distance traveled by a particle according to the velocity function. V of t equals 3t minus 5 meters per second over the time interval. So if I do this, let me draw a picture of this, and there's a little bit of technical part we have to get to. Okay, so 1, 2, 3. I'm going to draw this a little bit bigger there. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5 up here. Now, our original graph looked like this, and it crossed at 5/3. So 5/3 is right about here, and it's going to go up to at 3. 3 times 3, so it goes up to 4. 3 times 3 is 9, minus 5 is 4. So here's our graph again, just recreating this. And again, we have the upper portion and the lower portion. But when we're talking about total distance, what's going to happen is we're going to look at this. I want to change colors again. I ran out of colors. This, think of the lower portion flipped up here, so it's considered positive. So we want that amount. And the way we do this is we say the integral from 0 to 3 of the absolute value of the velocity function, v of t. So we want it as a positive, as a positive thing only. And so this turns into two different functions. So it turns it from 0 to 5/3. It's the negative of the velocity function plus the integral from 5/3 to 3. It's the regular velocity function. And again, the negative is because it has to flip it up, so it's not below the x-axis. So now it's positive area instead of negative area. And that's what that's talking about. So again, we're looking for total distance. Total distance would consider the function positive at all these places. So the part that's negative has to be flipped, and that's why we have that change into two different integrals. So given that, we would have the integral from 0 to 5/3 of, it's the negative of that 3t minus 5 plus the integral from 5/3 to 3 of 3t minus 5. Now we have two choices in evaluating the first part. We could just evaluate it like normal and apply the negative in the end. That's fine. Or we can swap the limits of integration. So it goes from 5/3 to 0, and then that takes away the negative. So do you want to swap the limits of integration, or do you just want to carry the negative through and it all works out in the end? What are you more comfortable with? You want to carry through? Okay. So we would have the integral from 0 to 5/3 of negative 3t plus 5 dt plus the integral from 5/3 to 3 of 3t minus 5 dt. And what's this going to do? Negative 3t integral is going to be integrating the antiderivative is negative 3t squared over 2 plus 5t. And we're going to evaluate this from 0 to 5/3. Now, I know 5/3 is probably going to make some people uncomfortable, but think about why we chose 5/3. Actually, it's still going to be a little, I won't say a mess, but it's going to be a little bit of fraction dealing with. And then plus the integral from, or the other integral is 3t squared over 2 minus 5, and that's going to go from 5/3 to 3. Now it's a matter of plugging in the limits of integration. So it's -3 times 5/3 squared over 2 plus 5 times 5/3. And then we have minus the quantity 3 times 0 squared over 2 plus 5 times 0. So that just takes care of the first part. Then the second part, we have plus 3 times 3 squared over 2 minus 5t times 3. I apologize for not having the t there. And then we have minus the quantity 3 times 5/3 squared over 2 minus 5 times 5/3. Okay, so we've got numbers in there. Now we've got to play with the arithmetic at this point. Okay, so this is -3 times, that's 25 over 9 divided by 2 plus 25 over 3. That's an interesting result. Then we have minus this next part, that's 3 times 0 squared, that's 0. And 5 times 0 is 0, so we could just call that all 0. So minus 0. And then plus 3 times 3 is 20. 3 times 3 squared, that's 27 over 2. We have minus 15. And then what do we have here? We have minus. So again, 3 times 5/3 squared, that's going to be 3 times 25 over 3 over 2 minus 25 over 3. Oh, that should be 9 here, shouldn't it? Okay. What do we get out of this? Remember this part before, this was just our -3/2. Over here on the left, -3 and the 9, that reduces, that makes that into a 3 down here. That -1 is still there. Okay, so what I'm seeing from that is -25 over 6 plus 25 over 3. Then we have plus this -3/2. Then plus the 3 reduces with the 9 there, makes that a 3. So we have, I should say, minus 25 over 6 again, and then plus 25 over 3. Common denominator is 6 if we want to do that. Except I see a minus 25 sixths and a minus 25 sixths. That'd make it minus 25 thirds, wouldn't it? So minus 25 thirds plus 25 thirds plus 25 thirds minus 3/2. I did this on purpose so that these can just cancel out. And then we have, again, 6 would be the common denominator, so it'd be 50 over 6 minus 9 over 6 is 41 over 6. And that's your answer. So a very different answer when we look at having the positive of both areas added up versus subtracting the two different areas where we have the -3/2. So the total distance traveled would be 41/6 meters, which is just under 7 meters, compared to -3/2 meters. Any questions there? Okay. Let's keep on moving. Find the net displacement. So net displacement compared to total distance. Find the net displacement. This is the first approach for the function f of t equals 1/2 e to the t minus 2 over 0, 2. Oh, and they also want both net and total. So our net displacement is just going to be the integral from 0 to 2 of 1/2 e to the t minus 2 dt. And so we're going to have 1/2 e to the t minus 2t from 0 to 2. So it's going to be 1/2 e to the 2 minus 2 times 2 minus the quantity 1/2 e to the 0 minus 2 times 0. Okay, so it's e squared over 2 minus 4, and then minus e to the 1, e to the 0 is 1, so minus 1/2. And okay, I must not have looked that one up. I have e squared divided by 2 minus 4 minus 1/2. I get negative 0.8055. Okay, so that's the one for the net displacement. Now let's get the total displacement. And for total displacement, we have to look at what our formula was. It was 1/2 1/2 e to the t minus 2, set it equal to 0. Because if we look at a graph of this, let's see if I can graph real quick, just relay the graph. Okay, the graph looks like this. So we have a portion that's going to be below the fraction bar and a portion that's above, and it crosses just before 2. So right there. Okay. So we take this 1/2 e to the t minus 2, set it equal to 0. So that's 1/2 e to the t equals 2, e to the t equals 4. So t equals the natural log of 4, which is what? I get 1.38. 38629. When I did this on my notes, I did this, the left as natural log of 4. So maybe we want to do that. Maybe we'll just leave it that way. So we'll have a portion that's below the fraction bar and a portion that's above the fraction bar. Oh, and it's just before the 2. Let's call it that. Get this portion above. Okay, so in doing the total amount, the total displacement, this first part we'll have to consider that the negative of 1/2 e to the t minus 2. So when we do this, it'll be the integral from 0 to the natural log of 4 of the negative of 1/2 e to the t minus 2 dt, and plus the integral from natural log of 4 to 2 of 1/2 e to the t minus 2. Again, two different limits, and then we just evaluate it, but the integral is the same. We've already done this integral once. This is going to be the negative of 1/2 e to the t minus 2t evaluated from 0 to 2. Nope. 0 to the natural log of 4 plus 1/2 e to the t minus 2t, evaluate that from natural log of 4 to 2.
I got a question.
Yeah.
So you pick natural log of 4, well, by obviously solving that.
Yeah.
Can you pick any number between 0 and 2?
No, you had to solve it, set it equal to 0 because you want to find the place it crosses.
Oh.
So it wasn't like randomly chosen natural log of 4. I had to set it equal to 0 to see, because that's the difference between where it was below the x-axis versus above. That's a turning point.
Okay.
Okay, so we evaluate this. This is the negative of 1/2 e to the natural log of 4 minus 2 times natural log of 4 minus 1/2 e to the 0 minus 2 times 0 plus 1/2 e to the 2 minus 2 times 2. I don't need this parenthesis or bracket there. That's a times there. Then minus, we have 1/2 e to the natural log of 4 minus 2 times natural log of 4. Okay. Okay, this gets interesting. Who recalls their rules of exponentials and logarithms? Okay, well, here's the rule. If you recall this, if you have, let's be pretty direct, e to the natural log of a gives you a. They cancel, their inverse functions. So that every time we have e to the natural log of 4, that's just a 4. So we have the negative of 1/2 of 4 minus 2 natural log of 4 minus, and then this is 1/2 times e to the 0. That's e to the 0 is 1. So that's 1/2. 2 times 0 is 0. Plus, we have 1/2 e squared minus 4. 2 times 2 is 4. Then we have minus 1/2. And e to the natural log of 4 gives us a 4 again. And minus a negative makes it plus 2 natural log of 4. And now it's a matter of the arithmetic portion. So we have negative 1/2 of 4 is 2. I'm going to bring the negative through now. Negative of negative 2 natural log of 4 is plus 2 natural log of 4. And negative of 1/2 is plus 1/2. Then we have plus 1/2 e squared. We have a minus 4. And then we have minus 1/2 of 4 is 2. And then we have plus 2 natural log of 4. What can we combine here? What's interesting is that, at least I find it interesting. I was hoping things would cancel more. We have this negative 2. We have a negative 4, negative 2. That's a negative 8. Then we have a plus 1/2. So we have a minus 7.5 there. So we have a minus 7.5. We have a 2 natural log of 4 and a 2 natural log of 4. So that's 4 natural log of 4. And plus e squared over 2, that 1/2 e squared. I think I got everything. And this comes out to be approximately 1.740. So that would be the total distance compared to the number we had above, that negative 0.8055 was the net change. I got a couple more of this section, then we're going to hit the next section pretty good. Any questions about this before we go on? You get two things. You get more exposure to intervals using definite intervals using limits of integration. And then we are also getting some application here of this total displacement. Okay. How many gallons of gasoline are consumed in this situation if the motorboat on a motor, if the motor on a motorboat is started at time equals 0, and the boat consumes gasoline at a rate which can be modeled for the first 2 hours as 5 minus t cubed over 100 for the first hour. How much gasoline is used? We're looking at just the first hour. So we're looking at the volume with respect to time. It's going to be the integral from 0 to 1 because it's 1 hour of 5 minus t cubed over 100 dt. So what's that antiderivative? I get a 5t minus t to the 4th over 4 times 100. You evaluate that from 0 to 1. So it's 5 times 1 minus 1 over 400 minus 5 times 0 minus 0 to the 4th over 400. I think you see the second part is just 0. Excuse me. So we end up with 5 minus 1 over 400, which is 4.9975 gallons. Okay, last problem in this section, very similar. Suppose that instead of remaining steady during the second hour of Andrew's outing, which this is Andrew's outing, doesn't say it's Andrew, but second hour of his outing, the wind starts to die down according to the function v of t. Oh, I guess this is a completely different problem. V of t equals negative 10t plus 15. In other words, the speed of the wind is given by, so v of t is negative 10t plus 15. So we have a piecewise function. Under these conditions, how far from a starting point is Andrew after an hour? So we look at two parts, the integral from 0 to 1/2 of 20t plus 5, and then the integral from 1/2 to 1 of negative 10t plus 15. So two integrals. What's the first one going to be? What's the antiderivative of 20t? 20t squared over 2. Good. Plus 5t. We evaluate that from 0 to 1/2. And then negative 10t plus 15. Very good. Okay, so we have reduce here, that's a 10. So we have 10 times 1/2 squared plus 5 times 1/2 minus 10 times 0 plus 5 times 0 plus a negative 10 and the 2 reduced makes that a negative 5. -5 times 1 squared plus 15 times 1 minus -5 times 1/2 squared plus 15 times 1/2. Okay. Honestly, I'm at this point where I just feel like putting this in the calculator. But. So 10 times 1/2 squared, that's 10/4 plus 5/2 minus 5 plus 15 minus negative makes it plus 5/4. Then minus 15/2. I did just put this in the calculator at this point. And then 10/4 that would reduce to be 5/2. Hey, Frederick. 5/2 plus 5/2 minus 5 plus 15 plus 5/4 minus 15/2. So I think we see right here, those go away with that. 15 minus 15/2 is 15/2 plus 5/4. Okay, so it's 30/4 plus 5/4, 35/4, which is 8.75.